equation stuff can be pretty tricky to learn for the first time, especially if you're still getting fresher on or a refresher on how factoring works. So I figured I'd write out a video for you that shows how I'm working through my own solutions. I hope that helps. All right, so question 1, we're looking to solve for the exact values of theta, if we can, within this domain 0 to 2 pi, so within a single rotation of around the unit circle. So we're talking about that. Now, I want to mention that question 2 asks us to solve a couple of these equations for all real numbers. So because of that, actually, I'm going to add a solution for all real numbers for each of the questions we worked through. So that depending on which question you chose, you can check both 1 and 2 together. All right. Now, when we solve trig equations, we're going to want to do these 3 steps each time. We're going to follow these steps. We're going to isolate our trig ratio, kind of get it on one side of the equal sign, and we may have to factor in order to do that. Then we're going to use this all students take calculus principle, and we're going to figure out what quadrant our angles could be in. And we'll talk about some cases where we may need to do something slightly different there because it's not in a quadrant, it actually terminates on the axis or one of the axes. And then we're going to use either special triangles or unit circle or inverse trig ratios to solve for our angle, whichever one is appropriate for our case. All right, so we'll look at A here. We've got, the question is tan theta is equal to -1 over root 3. Now, in this case, our first step is already complete. Our trig ratio is isolated already. So we're fine there. We're going to move on to step B. Part B here is we're going to use this idea that all students take calculus, or rather, what we need to remember that really stands for is that all ratios are positive, and S stands for the sine ratio is positive, and that means that the cosine and the tan ratios are negative over here. Tan ratios are positive in the third quadrant here. Of course, this is the first, second, third quadrant, fourth quadrant. And this one is that the cosine ratios are positive. And of course, that means that the sine and the tan ratios are negative in this quadrant here. All right, so we've got a tan angle, and it's of an angle, and it's a -1 over root 3. So it's a tan ratio that's negative. And that puts us in either quadrant 2 or quadrant 4. So I like to draw a little diagram like that to help me recognize which quadrants I'm good in and which quadrants this won't work in. And so then I say, okay, well, let's sketch that out. We're going to sketch the angle in a standard position. Of course, there's 2 angles in this case. So there's an angle that could terminate in quadrant 2. So we'll call that theta 1. How big is it? Tan opposite, okay. Okay. So draw a triangle, something like that. And you don't have to worry about this being to scale, really. We're not really, we don't always have to be sure how big each of the sides are. I think I actually drew this a little bit off, to be honest. It isn't quite right. This should be a little bit more acute, the reference angle, but we're not going to worry about that. The second angle terminates in the fourth quadrant here, so it should draw it out here, like so. And so what we know is that our tan theta is -1 over root 3, and that's equal to, I'll use a different color pen that shows better, it's equal to our opposite over our adjacent in our triangle, right? And what we got to know is that this negative here is either associated with the opposite or the adjacent, but not both. So that means we could say our opposite is -1 and our adjacent is root 3. And that would be this example here, where our opposite is -1 and the adjacent is root 3. Or alternatively, we could say that the opposite is positive 1, and the adjacent is negative root 3. And that's our second quadrant example here, where our opposite side is 1 and our adjacent is negative root 3. And of course the hypotenuse would be 2. And this is clearly one of our special triangles, right? This is a triangle, our 1, 2, root 3 triangle. So one of our jobs is to always know the, the angles. And so this is the pi by 6 angle here, and that's the pi by 3 angle here. I always remember pi by 3 is bigger, and so it's opposite the slightly bigger side, and pi by 6 is our smallest angle, it's 30 degrees, so it's opposite our smallest side. That's how I remember those guys. Okay, so that means if we fit this to our diagram here, that means this reference angle is pi by 6, and that reference angle is pi by 6 there. And so the last thing we need to do is be able to say, okay, well, how big is our angle? Angle theta 1. Well, it looks like it almost gets to pi, but not quite. So we'll say our theta 1 looks like it's like pi, but then we got to take away that reference angle there. So it's pi, take away pi by 6. And I'll let you work out the details there. I'm just going to write down the answer. That fraction becomes 5 pi over 6 when I subtract them. And theta 2, this angle looks like it gets all the way, oh, we didn't label that theta 2. That's what that angle is there. And it looks like we were going all the way to 2 pi, but then we're short pi by 6. So that'll be 2 pi, take away pi over 6. And so when we do that, 2 pi becomes 12 pi over 6. Take away 1 pi over 6, it becomes 11 pi over 6. And so this allows us to say, well, theta is 5 pi by 6 and 11 pi by 6. And those are our answers. Now, it's worth mentioning that, did I do that right? Yeah, I did. Okay. It's worth mentioning if I want to do this for all real numbers, this is between 0 and less than theta, which is less than 2 pi. And for our all real number solution, well, it turns out if you look at this, as long as you have one angle, which is, I guess, our theta 1, 5 pi by 6, and when we add pi, we get to another solution here in this other quadrant with another pi by 6 left over there. And if you add another pi, you get back here. Each time you're going to add pi, and that gets you the same ratio of -1 over root 3 each time. So it turns out that we could say it's 5 pi by 6 plus n 2 pi's, and 11 pi by 6 plus n 2 pi's. However, sometimes there's this scenario where these guys are exactly pi away from each other, and so rather than say it's this one plus 2 pi a bunch of times, and then there's this 11 pi by 6 plus 2 pi a bunch of times, it's actually a lot simpler to say theta equals 5 pi by 6, just the first simple angle, plus n pi's. And of course, we always have to state what n represents in this case. So n belongs to the integers. So it's an integer. And just as a reminder, that means n belongs to the integers. So any integer you choose, like say 10, if you add 10 pi to 5 pi by 6, you're going to get some coterminal angle, some other angle when you punch it into 10. It gives you -1 over root 3. Now, let's just test this while we're at it. So let's say we want to check an answer. So let's choose a random value. So I'll put that in the box so that if we're looking later, so that's all real numbers. Okay. All right. So we're going to test by choosing any value of n. Let's say let n equal 3. Okay. So we'll punch that in. We'll say then theta is 5 pi over 6 plus 3 pi. Okay. And so I could say that's 3 pi over 1. So I could make that 18 pi. You know, I'm just going to do it in a calculator. Why not? 5. Where's the pi button on this stupid thing? Pi divided by 6 plus 3 pi. Okay. And it gives us some gross decimal. And so that means that theta is equal to, well, maybe I'll write the exact answer here. 18 pi over 6 as 23 pi over 6, which is equal approximately to 12.04277.184 dot dot dot. Now, what happens if I say what's tan of 23 pi over 6? Or tan of 12.04277.184 dot dot dot. So the tan of that angle gives me a ratio of, wait, something's wrong. Oh, I'm in degrees, that's why. Okay, shoot. Uh-oh. Oh, I don't know how to do this on this calculator. Oh, there we go, 2 radians. So, sorry, so I should have done tan of 23. 23 pi divided by 6, close, negative tan of 23 pi by 6 equals negative 0.57735 dot dot dot. Is that equal to negative 1 over root 3? Let's just find out. Negative 1 divided by root square root 3. Well, what do you know? It's the exact same thing. Equals negative 1 over root 3. So, oops, I've been off screen for a little bit. Pardon me. And so that tells us that this formula, well, it's a test to test that formula. It has to work for this scenario. And it did with n equals 3. It doesn't mean necessarily that it is true just because we tested for one value, but we can maybe assume in this case that we're done. All right, so we got a lot of work ahead of us, so we're going to try to speed that process up for the next one. So we'll go through 2b. Oh, where did my questions go? All right. So this one's going to go a lot faster because we went through the first steps in excruciating detail with the first example. And so we're going to focus on anything new that shows up and slow that down. But beyond that, we're going to speed up a little bit. All right, so our first thing we need to do is isolate, right? So to isolate our trig ratio, we're going to add 1 over root 2 to both sides. And that cancels these guys out. So we get cosine theta is equal to 1 over root 2. Okay, isolated, done. Then we're going to use all students take calculus, and we're saying, okay, we've got a positive cosine ratio. So which quadrants can have a positive cosine ratio? It's this one and that one. We'll draw out our angles. We know it terminates in this quadrant, so we'll call that theta 1. And we can have another one that terminates down here, and we'll call that theta 2. And we know that this is the adjacent over the hypotenuse. So that means that we can draw a triangle. Say the adjacent side is 1 and the hypotenuse is root 2. Hypotenuse is root 2, and that makes this one a 1, 1, root 2 triangle, meaning our reference angle is pi by 4. Okay, so theta 1 is pi by 4. Theta 2 is, well, it's not quite at 2 pi, but it is 2 pi take away pi by 4, which is 3, oops, no, it is 7 pi over 4. Okay, those are the exact values for our solution. Now, if I want to get general solution, this is for 0 less than or equal to theta less than 2 pi. And this is for theta is all real numbers, or theta belongs to all real numbers. Then we get theta 1 is pi by 4, or I shouldn't say theta 1, that doesn't make sense. This is for all values of theta plus 2 pi times n, and it's equal to 7 pi by 4 plus n 2 pi. N belongs to the reals. We do a double Z. There we go. Done. That was way quicker. All right. So next, we get a strange scenario. We say, okay, well, for 2c, I'll just write that down here. So 2c says that tan of our angle is undefined. Weird. Okay, cool. So it looks like our trig ratio is isolated, so that's fine. And then we have to say, well, in which quadrants is tan undefined? Well, it's positive here and here, it's negative here and here. So what this means actually is that this is going to be on our unit circle. So you might notice there were some subscripts that we skimmed over in these steps. So if our ratio is equal to 1 or negative 1 or 0 or undefined, the angle may, emphasis on may, terminate on the axis. If that's the case, then we need our unit circle. Okay, so we're going to draw out a unit circle here. A circle with a radius of 1 unit. It's point 1, 0. 0, 1, point negative 1, 0. These are the places it'll hit. I haven't drawn the circle yet. The circle's here, of course. And 0, negative 1. And so we know that tan always corresponds to the y-coordinate divided by the x-coordinate. And of course, while we're at it, sine is always equal to the y-coordinate on the unit circle, and cosine is always the x-coordinate on the unit circle. Okay, so where are we undefined? Where, when we divide y by x, are we undefined? Well, if I divide y by x here, I get 1 over 0. So that's undefined. So that's theta 1 is pi by 2. I should probably label that axis. Pi over 2, and this is the 0 and 2 pi axis. This is the 3 pi by 2 axis, and that's pi. All right, and the next place is, well, if I take the y and divide it by the x here, I get 0 over negative 1. That's just gives me 0. 0 over 1 is 0. But down here, well, that's theta 2. That's our second angle, because that gives us negative 1 over 0. And remember, if you punch that in, negative 1 divided by 0, you're going to get a math error or some sort of domain error in your calculator because you can't divide by 0. So our two answers here, theta is equal to pi by 2 or 3 pi by 2. And that's, of course, our values from 0 to 2 pi. But we're also doing all our all real number solutions so for question 2. So we're kind of working ahead. And that would give us, notice this is another scenario like in question 1, where these angles are exactly pi radians away from each other. So rather than adding 2 pi to this one over and over again, and 2 pi to this one over and over again, I can get from one to the next just by adding a single pi. So theta is equal to pi by 2 plus n pi's, where n belongs to the integers. And that's our theta, it belongs to the real numbers solution. So there's two solutions we've written there. One for question 1, one for question 2. All right, moving on. All right, question D. 2 sine theta is 1. 1D. I think I actually called those questions 2B and 2C, but those are 1b and 1c. All right, so we got 2 sine theta is equal to 1. Okay, cool. So we're going to isolate theta. And the way we're going to do that, we're going to isolate sine theta. We're going to divide by 2 and divide by 2. And that gives us that sine theta is equal to 1/2. Okay, so it's a positive ratio. So where is that? That's in the first quadrant and the second quadrant, but not in this third or fourth. Okay, so we'll sketch those guys out. So we'll say, okay, our first angle terminates here, so we'll call that theta 1. Our second angle terminates out here, so we'll call that theta 2. And we know that this is an opposite side is 1, and our hypotenuse is 2, so we'll label that up. An opposite side here, and adjacent, and opposite side is 1. So that actually tells us, again, we're in our familiar 1, 2 root 3 triangle, and the reference angle here is going to be pi over 6. And so we can see from there that our angles are pi by 6, and, well, we're almost getting to pi, but we're not quite there. So we're missing pi by 6, so the other one is, so theta 1 is pi by 6, theta 2 is pi take away pi by 6, which is 5 pi by 6, and I'll let you figure out how we got that yourself, but ask me if you're not sure. And those are our answers. And those are our answers for our values from 0 to 2 pi. Those are our only solutions. However, we're going to write down solutions for question 2 as well, which asks us to choose any 2 of them. 2 of these questions from question 1, and express them for when theta belongs to the real numbers and not just all real numbers, not just the values from 0 to 2 pi. And so we're going to take those 2 angles and say, well, our angle could be pi by 6 plus some number of rotations, n 2 pi's. And it could be 5 pi by 6 plus n 2 pi's. And of course we have to define n. N belongs to the integers. Okay. So 1e plus 1e asks is cosquared, theta is 1. Okay. So 1e says cosine squared theta equals 1. What we got to remember when we see that squared is that really means cosine theta all squared is 1. So we got to do the opposite of squaring. We'll square root both sides. We've got to remember the plus and minus there because there's actually 2 different sets of answers that would be equal to the square here. So those guys cancel here, the square and the square root. And that gives us that cosine theta is equal to plus or minus 1, which is to say cosine theta is 1 or cosine theta is negative 1. And those are 2 different scenarios. Now, I want to remind you that we were saying that if a ratio is equal to 1 or negative 1, it may terminate on the axis, and this is the case that is true here. The only case that's not true is if you have tan theta is equal to 1, and that actually ends up giving us our own ratios, 1 over 1. So this is a unit circle scenario, both of them are. So I'll just draw out the unit circle quickly. And label up our values, 0, 1. Oh, no, 1, 0, 0, 1. Oh, gosh. I'm a little tired, I could be honest. 0, 1. Negative 1, 0. And 0, negative 1. And we got to remember that cosine is always our x-coordinate of the unit circle. So wherever we are in the unit circle, if our angle is theta, the cosine of that angle theta is our x-coordinate. Even if we're in the middle. So it's not just at these 4 quadrants. These tend to be the ones where it's most useful when we're solving for a ratio. All right. So when is our cosine value equal to 1? Where does it correspond to 1, our x value? So we can see, oh, it's right here. It's at 0 radians. So one of our values is that theta is equal to 0. right? Because that gives us an x value of 1. And the other one is that cosine theta is -1. If we're looking for an x coordinate of -1, and that's here. So that tells us that theta 2, which I'll draw in here, is pi radians. So if you do cosine of theta or cosine of pi and you square it, it gives you 1. Let's just test that. Cosine 0 is 1, square it, you get 1. Cosine of pi is -1, square it, you get 1. Just two solutions. So theta equals 0 or pi. And we'll just specify those are between 0 and 2 pi. And of course we write our solutions for all coterminal angles, and you can see here you would add pi each time to get to a new coterminal angle. So actually I could specify this, or I could simplify this by saying actually theta is 0 plus n pi's. Well, 0 plus n pi's is just n pi equals n pi, where n belongs to the integers. So that is the answer for all real numbers. Theta belongs to the reals. Okay, moving on to F. Okay. So this isn't a nice pretty fraction ratio like these guys, so we'll just deal with it as it is, you know. Well, who knows? We'll see what happens. 1F, we'll just play around with it. First got to isolate our trig ratio no matter what. Okay, so we got 3 sine theta. That's equal to 0.0446. And we got to get theta by itself. Pardon me, we got to get sine theta by itself. So we're going to divide each side by 3. And we get sine theta is equal to 0.0446 divided by 3. And we get 0.014. How many decimals am I going to write? I'm going to write 2. 8, 7. That rounds up to a 7, of course. All right. Now, that's a positive value. It's a positive ratio. So I could write that in two ways. I could write that as 0.01487 over 1 to help me think of my opposite over my adjacent. Over my hypotenuse, pardon me. Or I could say, if I wanted to, this is in tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So I could say it's 1487 over 100,000. Really, you could do either one of those. I'd say this one maybe is a little bit simpler to think about, but it doesn't really matter. The ratio of those is equal to the sine of our angle. Okay. So what do we know? We know that, what quadrants are we in if these are our values? Well, we know that sine is positive. Oops, here and here, but not here and here. So we can sketch those triangles out. These triangles are going to look kind of funny because in the first quadrant, you're going to get one where the opposite side is really small relative to the hypotenuse. So I've underestimated that there. Or I've overrepresented how big this side is relative to this one. And over here, and this is our second angle, we'll call that theta 1, theta 2. That's pi, of course, 0, pi over 2. And again, we have this opposite of 1487 over 100,000. Okay, fine. So we're going to have to use inverse trig here. Now, because this is not a special triangle, and it's not on our unit circle. So therefore, we need inverse trig. So we can find our reference angle using inverse trigonometry. So to find the reference angle, we'll say, okay, well, sine theta is equal to 0.01487, and we'll take the inverse of that. So we'll say, well, we'll do sine -1 on both sides, and that cancels those two out. And so that gives us that theta is equal to sine -1 of 0.01487. And that's our reference angle. So that's a little angle, reference angle there. All right, so our inverse sine function is 0.01487. What? Why is that true? Oh, it's that weird situation where sine x approaches x. Oh, cool. Yeah, okay. This is super weird, guys, but it's just a fact. You learn about this principle a little bit more in trig, but I think when our angle is sufficiently small, the angle, the sine of an angle is actually approaches the value of the angle itself. It's weird. All right, so anyway, the reference angle is actually 0.01487. And we'll just write in here a little note. That's weird, but true. Seek calculus if you want to learn more about that. You know what, actually, 0.01487. I just want to double check that. Yeah, okay, cool. All right. Okay, so that's our reference angle. So our two angles then, so theta 1 actually is just that value, 0.01487 radians. Okay, theta 2, well, it looks like it's pi take away that value, that reference value. So it's going to be pi subtract our reference angle, which is pi take away 0.01487 radians, equals pi take away 0.01487, 3.127 radians, approximately. So we can say that theta is 0.01487 rad, or 3.127 rad. Those are our values from 0 to 2 pi. Those are our only solutions, but of course there are infinite solutions. So it looks like a 2, there's a 3, okay. So we could also say that theta is 0.01487 plus n 2 pi's, and 3.127 plus n 2 pi's, where n belongs to the integers, and that's when theta belongs to the reals. Those are our answers for question 2. Okay. Moving on, let's do 1g. All right, so 1g, this one looks funny. It says sine theta tan theta is equal to sine theta. So just looking at this, I can probably conclude some things here. Probably that tan theta is equal to 1, and that maybe I'm not sure what that concludes about sine theta, but maybe it means that theta could be anything. Maybe we'll see. Okay, so we got to isolate our trig ratios, and we had said before this may involve some factoring. And if you have multiple trig ratios, you're just going to have to factor this guy first. So we get everything to one side, so we'll take away sine theta. We'll take away sine theta. And so then we get sine theta, tan theta, take away sine theta, is equal to 0. And then we're going to factor. I can see the sine theta as a common factor, so we'll factor it out to the front. Sine theta equal to, and then we got leftovers, which is tan theta take away 1. That's all equal to 0. So we can conclude that either one of those scenarios is equal to 0, because the two multiplied together get 0. So we could conclude either that sine theta equals 0, or that tan theta minus 1 is equal to 0, which of course would imply that tan theta is equal to 1. Okay, so those are two different trig ratios. And they're going to require different scenarios. So this one is going to be on our unit circle. It's one of our zeros. And we can say we want to remember that sine always corresponds to the y value. And so remember sine is equal to our y value here. So we have this point 1, 0, 0, 1, negative 1, 0, 0, negative 1, and so on. And our y value is 0 at this point here and that point there. So that means the two angles that satisfy this are that 0, or theta could equal 0, or theta could equal pi. So those are just from the sine theta is 0 alone. However, we also have other potentials here. So tan theta is equal to 1 over 1, which is our opposite, over our adjacent. So that could also be equal to, we have to know, negative 1 over negative 1. And so those two scenarios, of course, where tan is positive, that's here and here, right? You can't have a positive tan ratio in either of those quadrants. So the other possible scenarios are that we have a tan ratio. So maybe I'll draw a little dashed line here, because it turns out we don't want to have it be confusing when people are looking at our solutions here. So we have one angle here, we'll call it angle 3, and that's equal to 1, 1 on the opposites, which is 1, 1 root 2 triangle. And of course angle 4 back here, same thing, except it's negative 1 root 2. Our reference angle here is pi by 4, of course. So that means it's pi by 4. So we also get an angle equal to pi by 4. And I'll call that theta 3 and theta 4 is equal to 5 pi by 4. So then we say, okay, theta equals, I like to put them in order from biggest to smallest, so 0, pi by 4, pi, or 5 pi by 4. Those are our solutions. But of course, those are our solutions from 0 to 2 pi. So we should also recognize that we can get back to any solution by adding pi in both of these scenarios. Pi is half of a rotation, gets us to each one of our solutions once. So we can say actually that theta is equal to 0 plus n pi's, which is actually equal to n pi, or theta is equal to pi by 4 plus n pi. Theta equals, so we can take that together and we can say theta equals n pi or pi by 4 plus n pi, where n belongs to the integers. And of course that's for our theta belongs to the reals scenario.